Hello, I'm Julie Lerman.
And I'm Steve Smith. Welcome back to Domain-Driven Design Fundamentals. In this module, we'll continue exploring the elements of a domain model as we dig into value objects and domain services.
Value objects are a confusing concept, so we'll begin by looking at where they fit into the mind map and introducing what makes an object a value object and how they relate to entities in a model.
We'll share some more guidance from Eric Evans and Vaughn Vernon, and then show how we've implemented value objects in our code.
Next, you'll gain a high-level understanding of domain services and solidify that by exploring their features and then some examples of domain services. When introducing entities, Steve and I talked about objects that were defined by a thread of continuity and identity, not defined by their values. So what about objects that are defined by their values? These are called value objects, and they play an equally important role in a domain model as entity objects do.
A value object has very specific characteristics. It is an object that is used to measure, quantify, or describe something in your domain. Rather than having an identity key, its identity is based on the composition of the values of all of its properties. Because the property values define a value object, it should be immutable. In other words, you shouldn't be able to change any of the properties once you've created one of these objects. Instead, you would simply create another instance with the new values. If you need to compare two value objects to determine if they are equal, you should do so by comparing all of the values. Value objects may have methods and behavior, but they should never have side effects. Any methods on the value object should only compute things. They shouldn't change the state of the value object, since it's immutable, or the system. If a new value is needed, a new value object should be returned.
Don't confuse the value objects pattern with C# and .NET support for value types and reference types. Custom value types in C# are defined with structs, while reference types are defined as classes. In DDD, both entities and value objects are typically defined as classes. Classes have advantages over structs when it comes to encapsulation and support for inheritance-based extension and reuse.
To help you better understand the basics of value objects, let's take a look at some value objects that you probably use all the time as a developer. The most commonly employed value object is a string. In .NET and many other languages, a string type is immutable, and you now know that immutability is one of the key attributes of a value object. A string is a collection of characters, and the combination of all those characters give that string meaning. For example, CAR in English, a car. If a string were mutable, we could change the R to T. Now the string is CAT, a cat, which has a very different meaning than a car. Or we could add a letter, maybe put an S in front of it, turning car to scar, also completely changing the meaning of car. But it's not just the array of characters that gives a string its meaning. The order of them is also critical. Just think of the word dog, D-O-G. Shifting its letters around gives us something with a very different meaning.
So one of the things that .NET makes it really easy to do is to modify strings. Like you can change the length of it or make one all uppercase. But when you call, for example, toUpper on a string, it doesn't just change that string object. It gives you a new instance of a string that now has all uppercase characters.
Many developers say that monetary values in financial systems have been perfect candidates for value objects in their system. And Ward Cunningham provides us with a really helpful example, a company's worth. If a company is worth $50 million, that means something, $50 million. It's a very specific measurement. 50 million on its own is not a measurement. It has no meaning without the unit, which in this case is dollars. But dollars alone doesn't describe worth either. In fact, dollars doesn't really help, does it? Because is it US dollars or Canadian dollars, Australian dollars? It only makes sense when you put the two together as 50 million US dollars. There's actually one more factor to take into account is the point in time of this $50 million because of the way financial systems work and the fluidity of monetary values.
We could still just have the two properties in this company class, but by creating a value object, you also protect and constrain the measurement. For instance, we might have a class called company. It might have one decimal property that represents the worth amount, and another string property that represents the worth unit. The problem with this approach is that it doesn't tie these properties together in any way. These two properties appear to be independent of one another, but they're obviously closely related. If an update is made just to the worth unit string, it could obviously have a tremendous impact on the company's worth as a combination of these two concepts. 50 million rupees has a very different worth than 50 million US dollars. To ensure nobody can set the unit without also specifying the amount, a separate value object can be introduced to represent the entire worth concept. This ensures the entire object must be updated as a whole. Since the worth type is immutable, the only way to make updates to the worth property on the company class is by replacing the whole instance with a new one, not just changing an isolated field.
A value object is not always for a measurement, though. It can be another type of description. Eric Evans calls out dates as a great example for value objects. I've used this one often, date time range, and it was perfect for the vet appointment scheduling app. We usually set a start and end time together, and can't really set one without the other. Also, we often need to pass the two values, start and end time, around from one method to another. So we've encapsulated them in a value object called date time range. The properties have private setters, which makes the object immutable since we can't change them. We aren't showing the full logic of the class here, but when we look at the value objects in our application, you'll see more of how we implement a value object in our software to ensure that it meets all of the attributes, not just immutability, but how we handle equality comparison and other logic.
In his book, Implementing Domain-Driven Design, Vaughn Vernon recommends that we should try to use value objects instead of entities wherever possible. He says, "It may surprise you to learn that we should strive to model using value objects instead of entities wherever possible. Even when a domain concept must be modeled as an entity, the entity's design should be biased towards serving as a value container rather than a child entity container." What this means is that you'll find that your design will have a number of entities who have very little logic of their own, or very few primitives as their properties, but instead will have a number of properties that each are themselves a value object.
So he's not saying everything should be value objects, but that it's probably our natural instinct to start by thinking of things as entities, and then maybe once in a while go, oh, maybe that should be a value object. So what Vaughn is suggesting is really start by thinking every time, should this be a value object? And you will surprise yourself at how many times something that you originally might have thought of as an entity really does make a lot more sense as a value object.
Or sometimes when you're looking at an entity, there might be a couple of properties that seem to always go together. You might be able to bundle these properties into a single value object.
It's interesting to note that identity values can be treated as value objects as well. In many systems, entities have a primitive type, usually int or GUID, as their ID. But this means that it's easy to substitute a client ID for a patient ID if developers are not careful. By creating actual value objects for client ID and patient ID, which can still be stored as ints or GUIDs, it can eliminate this kind of error from our design.
Here's an example of a client class that's inheriting from base entity, but specifying that the type will be client ID value object rather than a scalar type like int or GUID. That's followed by a service class that has a create appointment for method, which takes a client ID and a patient ID. If those IDs were both GUIDs, the runtime code would allow you to accidentally pass them in the wrong order because the signature is only constraining that you pass in two GUIDs. And that could create a big problem when you're trying to build an appointment. But with the specialized value objects, you can tightly constrain the parameters to avoid this problem, rather than adding a lot of extra logic elsewhere to protect you from making that mistake. For me, this highlights the beauty of DDD thinking. With this little bit of upfront work, you're removing the complexity of solving the kind of problem that could be created by accidentally transposing the client ID and patient ID. In our conversations with Eric Evans, we asked him for his thoughts on putting logic into value objects. He told us that he thinks value objects are a really good place to put methods and logic, because we can do our reasoning without side effects, and especially the complications that identity brings along. All those things that make logic tricky. We can put functions on those value objects and then do the pure reasoning right there in the value object.
Eric also called out date libraries as a good example of a value object. They perform common functions on dates, so we don't have to keep coding them ourselves in our entities or services. For example, a date library could be used for calculating a person's age from their birth date. As long as the library causes no side effects to the date in question, it can work well as a value object.